Hi, this is the next video in a series of videos on LCD technology and designing, in this particular case designing a custom LCD display. In previous videos here we've looked at just LCD technology overview in general and how to drive different types of LCDs. So they'll be linked in at the end of this video and down below if you haven't seen that. But today we're going to have a look at what it takes to design effectively your own custom LCD like this. In this particular case, this is for the new µSupply. Yes, we are working on it again, and we're going to design our own custom LCD. Won't necessarily go into the reasons why, it's just because we can and we like it. It's a good enough reason, and they're cheap. So there's various reasons why you might want to design your own LCD, and rather than use an off-the-shelf one like a dot matrix LCD or a dual line character-based display or something like that. So in this case, we're going to design a fairly complex LCD like this. By complex, I mean it's actually got a lot of segments in there, and basically, as we'll come to see, the number of rows and segments dictates not only how complex the LCD is, but how complex the LCD driver is as well. So let's take a look at it. Now, I'm kind of actually jumping the gun on this video because I don't actually have an LCD to show you. We haven't actually had this one manufactured yet, so this video is more about what what is involved in just specifying up an LCD and then choosing a manufacturer. And fingers crossed, in the end, it's going to work, and we'll show you that in a future video. Now, I'm not actually going to recommend a particular LCD manufacturer in this case. I may not even say who we're actually going to get ours manufactured with. It doesn't really matter. They're just dime a dozen. I mean, just go into Google and type in custom LCD manufacturer, and you'll find like a ton of them. And if you go into, say, Alibaba and just, custom LCD, something like that, I'm sure you'll find, here we go, custom LCD manufacturers. You go online, talk to them, and they'll basically give you a quote on the spot if you've got all the relevant information available, the size, the number of segments, and what type you want, and things like that. So, like, it's just no shortage of choices. And like from one of the first ones on Google here, I don't recommend them, but this is some one popped up, and they do all sorts of different custom types. We've got COG, they do OLEDs, they do character-based ones and dot matrix ones, all sorts of custom, almost anything you need for a custom LCD. Tell us the price, son. All right, this is by far not the lowest price you could get. We've talked to several manufacturers. They're all in China, and basically we chose one of the cheapest ones that our Spidey Sense told us that wouldn't, that could do the job for us. Some of them just, don't communicate properly. Often English language barrier and things like that can be a problem. But sometimes, like, if ones are asking the wrong question, you might just ditch them. So this price, we just have a one-off single price here that just came from a manufacturer that we were looking at, and these were the basic specs that we told them. We need a positive reflective display, the power supply, the duty cycle, the bias frequency that we'll have a look at that in a minute, the viewing angle, standard sort of temperature range, what type we want, a pin connection method in this case, although we've got the others down here, and just a regular black and white with 0.1 millimeters clearance and minimum track width, and we'll talk about that shortly. And basically, look, here we go. Unit price in US dollars. What was this quantity for, David? 1,000 quantity. I thought it might be. 1,000's usually like a nice ballpark figure, and it's not breaking the bank really. Here it is. So for a regular pin-based one, which is the one that we're going to get manufactured, we're going to get one like just your regular LCD, custom LCD glass like this with the pins on the side there. And of course, you don't have to have the pins. You can remove the pins, and then you can use the zebra strips as we talked about in a previous video, and that you might shave a few cents off the cost there if you don't have the pins on there, but it's basically the same glass for the pin. So $1.47 in 1,000 quantity. And then it's actually a bit of a jump. It's not usually this much of a jump, but in our case, this is what we were quoted, $2.36 for the FPC, or the flat flex connector version. That's a bit strange because it's just basically conductive gluing a flat flex onto the glass as opposed to putting the pins on. So that was a fair jump to go to that flat flex. And then COG is the chip on glass, which has the LCD driver built onto it. And we could have went for that, but look at the price difference, $3.71 each in quantity versus $1.47. And as we'll see, we'll take a look at the driver chip that we're actually going to use, and the price just doesn't justify using COG. But it may, for your particular purpose, depends on the manufacturer. If you don't have space on your PCB to lay to put your driver chip, for example, especially if you've got a lot of segments like we've got on this custom LCD, that could be a real driving price. Now, the tooling cost, which is a one-off non-recurring NRE, they call it, non-recurring engineering charge or tooling cost, $230. You know, it's not a big deal. So really, what's that? You know, under $2,000 for 1,000 LCDs, including the tooling cost. And from this particular manufacturer, the turnaround time was 2 to 4 weeks or something like that. You probably could get like samples quicker if you needed to. And the flat flex one, not much more tooling cost, $285, but it was a big jump up to the chip on glass one, which was $1,385. So, you know, if you're only making 1,000 widgets, and you have to amortize that tooling cost over 1,000 units, for example, then that's an extra $1.38 per unit. BOM cost you've got to amortize over. So that, you know, that could be fairly substantial. Of course, if you're only making 100 of something, custom LCD, it might be worth it because it's the only way you can get your product designed. Like the custom LCD makes your product. In that case, you've got no choice. But generally, you know, your tooling cost might actually eat away at you in smallish volumes. Okay, so you've decided you want a custom LCD because it's going to make your product look more professional, gives you something that you can't get with a dot matrix LCD, gives you better viewing angle, better contrast or whatever, or you're simply trying to save costs, which is often a dominant reason, and why, you know, a $1 watch or something, you're buying a little farty novelty gadget and it's got a custom LCD in there, because in volume, they're cents each, really, you know, especially if you're making 100,000 widgets or whatever. So cost is often a big driver. But anyway, you've decided to do that, and the first thing you need to do is know how many segments you've got. And in our particular case, this is the drawing, which we'll go through shortly. But basically, we have 212 segments on this thing, because we have 5 displays of 4 digits each with the 7 digits each, plus you got the decimal points, plus we've got a bar graph, everything else, some miscellaneous enunciators and all that sort of stuff. So 212 segments is actually a lot. So we're basically going to have to look for a driver chip which has basically 256 segments, but as we've seen in a previous video, that you have to separate them into common drivers. So in this particular case, we basically need a chip which has 8 common pins, as they're known, and we have a pin table here to be filled in by the manufacturer, as we'll explain, which has, because we've got 40 pins, we just decided to have 40 pins there because that's enough to do all of the segments we want in an 8 common by 32 configuration. So we need to choose a driver chip which has 8 commons and 32 segments at least. So that works out to a lot of pins, and this is why you might want to go to a COG display, chip on glass, because it has the driver chip built on. So you can simply talk to it via an I2C bus or an SPI bus or whatever, or the regular Hitachi interface LCD drive, or whatever you choose to. In this particular case, no, because we've just got the pins, or the flat flex, or the zebra strips. We have to drive every one of these 40 pins. So that becomes a problem. Now, if you've got a relatively small LCD, you can use your existing microcontroller that you already plan to use, or you can choose a variant of the microcontroller that has a built-in LCD driver, and a lot of them do. I used it in my 121GW multimeter, for example. I chose a particular ST ARM32 processor, which had a built-in LCD driver that had the number of rows and columns that we needed. Now, if we go over here and have a look at, say, the ARM STM32 ultra-low power MCU line, which we happen to be using, and also we use this in the 121GW multimeter as well. We chose a particular variant with the built-in LCD controller that had enough pins. And what I've done here is I've sorted the parametric table here. You'll hear this term a lot, parametric table, and if you don't know what that is, it just means having all these different parameters, hence why it's called parametric table, of the chip. You know, you've got supply voltage, min-max supply current, and you can put operating frequency AD converters, and in this case we can actually have whether or not it's got a display controller. So I've sorted by the display controller here. And you have to be careful because sometimes these aren't particularly accurate, these parametric searches. So look, if you just look at this first page here, you might think that these STM ARM micros, I think that's the one we're using, the L152, one we're using on the 121GW. Anyway, it's got like 4 by 16, 4 commons, that's what it means, 4 commons by 16 segments. But hey, let's just go scroll through a couple of pages. Aha, 8 by 28. That one there would actually do it. So let's have a look at the next page. Here we go. It's got 4 commons /31 or 8 by 28. And actually 8 by 28 would do it. That would do the 121 pins that we actually need. But the problem with this is that it may force you into a much more expensive microcontroller because it's got 512K of memory, or it's got, you know, this and that. It's in a bigger package, it's got more pins, and it could double the cost of your chip. Your micro might be $1.50, for example, the one you were looking at using, and then when you search for one that has the built-in LCD as well, bigger package, whatever, it might force you into another model, or whatever, it could double the price to $3, for example. So you're effectively paying, in that example, $1.50 for the LCD controller. And we could actually find one that actually did the job for us here. Any one of these 8 by 28 ones would actually do the business, and probably if you went in and see the data sheet, you could choose a different package size to get that perhaps. And it's the same across any or, you know, a lot of these microcontroller manufacturers, similar sort of story, same story effectively across them. But you know, $1.50 extra, for example, or it could be 50 cents or whatever. But if you can get a separate LCD controller for less than that, then you're ahead on your BOM cost. You're winning. And of course, having a separate LCD controller chip can also have advantages in that you can physically place the chip somewhere else on the board, like actually under your LCD itself. So you get a nice routing of your pins and everything. You know, they fan out quite nicely to the pins of your LCD, for example. Whereas if with your micro, you might need that somewhere else on your board, and then your LCD might be up here, and your micro needs to be down here for other reasons, you know, because it's got the ADCs built in that you're using and you want, and you've got to get all these LCD lines right across the PCB. It can be a pain in the butt. So often decisions like that may drive you to use a separate LCD controller, like we've got here. In our case, it was just cheaper to get an external LCD controller than to use one built into the micro that we wanted to get. So we can go over to Digikey, we can search for our LCD, or Mouser, or whoever your favorite parametric provider is, and allows you to, like, you know, search by columns and all the different characteristics and stuff like that. So we can, I've already drilled down to regular segments. Well, look, we can go down. We need like at least 215 segments. So we need at least those. Whoa, 600 segments. That's huge. So we can apply the filter and have a look at the chips available, and they're going to be reasonably large pin count LCDs. Now, LCD drivers. Now, here's one from NXP, for example, the PCF8545. That's an old Philips thing. I think old Philips part number, you know, 80, and I've sorted by price here, so lowest one first. So it looks like the lowest one that might do the job, 80 by 4. No, that's not going to do it. 80 by 87 cents, $1.40. Getting a bit pricey. But I happen to know that they don't sell them on Digikey, but let's go over and see the display controller which we've actually chosen. It's actually a Holtec, and Holtec manufacture little cheap, like 8051 compatible micros and things like that that you'll often find in farty novelty toys and stuff like that. And they also do a range of LCD controllers here, and we're actually going to use the HT1622 here, and it happens to have 8 comms and 32 segments, and that's perfect for our 8 common display here. And the other thing about this Holtec LCD driver is that it's quite reasonably priced. I think we got some quotes somewhere like AliExpress. You've got a wheel and deal with people on AliExpress, but it could be as little as 10 cents in lowish volume. So we shouldn't pay a huge amount. So as you saw before with the cost breakdown of this thing, the COG thing at $3.71 a piece compared to $1.47 here, then it's easily paid for this chip. 20 and 40 cents. It was pretty cheap. So considering that our LCD only costs $1.47 in quantity once we've amortized that $230 cost, but that's not a big deal. It comes in under $2 for that LCD solution. And I know a lot of people might say, well, I can go on eBay and I can get one of those old Nokia phone LCD things for a couple of bucks. Well, good on ya. If that suits your project, fine, do that. More power to you. But if you want, there's very good reasons why you might want to design a custom LCD. As I said, the look and feel and all that sort of thing, the view angle, the contrast, all that sort of stuff. And really in volume, it can get cheaper. I mean, this is not a particularly cheap quote. We can almost certainly get cheaper than this quote if we shop around. All right, so we're going to need to know several things in order to provide this information to the manufacturer so that they can give a proper quote on our custom LCD. So in this particular case, we've got like a quarter, the chip that we're actually using uses quarter bias, 8th duty cycle, and the refresh rate or frame frequency of 64 Hertz here. So then we can translate that back over to our manufacturing drawing, and this is where your manufacturing drawing comes in. We've kind of gone to town a little bit on this one, so you don't have to get as fancy-pantsy as what we've done here. I'm using Inkscape here. David did this one. I didn't draw this up because my Inkscape skills are non-existent, but he basically went in and drew a vector-based graphics for all of these character displays here. And we've got a manufacturing table. It's similar to when you get a PCB manufactured, very, very similar, and I've done videos on this about actually providing manufacturing information in the Gerber files, and this is a similar thing what's going on here in our PDF manufacturing document here. We've got our display area here, 50 by 54, our physical area. So the display area is actually the glass area that they need to manufacture. The physical area allows for pins or whatnot, and we're saying we can the length that is modifiable by the manufacturer if they want, things like that. Just give them, if you give them real hard constraints, then they may actually pad the quote up because they don't have the flexibility to do whatever they want. It might be harder for them. So just be aware of that. Give them as much flexibility as you can, but we're saying a nominal power supply of 3.3. We're saying the duty cycle, the 1/8, the bias of 1/4, which I've covered in a previous video, and the frequency 54 Hertz. And the viewing angle, now this is an interesting thing. This 600 bottom, this is actually kind of confusing, but it's kind of an industry standard kind of thing. Let's have a look at this. This is Handtronic's explanation of the LCD angle, and basically what it comes down to is, are you going to, here's your product, are you going to look at your LCD from the bottom? So if it's lying on a table like a calculator like this, you're looking from the bottom. So we would choose the 6 o'clock bottom position, and they work in terms of time on a clock. So that's just how they do it. So that you would specify that you basically want your optimum viewing angle in the lower, like looking from the bottom. But if you're designing a rack mount thing that's sitting low or something like that, or you're installing it where somewhere a person might have to walk by and look down on the LCD, for example, then you would specify the 12 o'clock top position. So we're just specifying, because our particular one, we're going to be looking from that angle. Now you can actually adjust this, of course, using the contrast. So if you have it set to the center, you can actually use the contrast to adjust either way, and you've no doubt seen that on products that have adjustable viewing angles. You can actually adjust them above and below the plane. But you want to specify, if you know you're going to use it in a particular orientation, specify, in our particular case, the bottom orientation there. So that's what we've specified there, and the operation temperature range is pretty basic. And connection method, we've got FPC ribbon. We don't want that, David. We have to fix our drawing. We want pin. I don't think this is the final one. Anyway, and optional, including, quote, the COG. So there's just some information there for the manufacturer, so they have it in a document. You can provide this in the email or the chat with them or whatever, but it's just nice to have a document like that. And we've actually specified a pin here, and we've gone rough pin dimensions, but just leave it up to the manufacturer. You don't have to include any fancy stuff like this. Now we've given them a table here to fill in. We could, of course, hard specify which segment we want connected to which pin, but then it's like PCB routing. You can't just do it willy-nilly. You can't have one over here going, like 2 segments over here and then go into opposite sides. It just screws up the routing on the glass, because it essentially is like a PCB layout, and they manufacture these using layers just like on PCBs, and the photographic method with the conductive paths in on the actually etched onto the glass itself. Now, so generally it's best to leave it up to them, and you don't even have to give them this table. They will simply provide you with a final table when they ship you a unit. Here it is, here's your pinout. Just leave it up to them to decide which is connected to where based on their particular routing. And the thing is, the more, if you've got a really tight LCD where the segments are right near the edges, like on this particular one, then they may be very constrained. They will be very constrained in the routing that they can do to this. So you may not get what you ask for in that particular routing case, and it depends on whether the pins are at the top or at the bottom. That can make a heck of a difference, or whether or not you've only got pins on one side or connecting, you want them to come out one side, depending on your system design, then, it becomes quite complicated. So, but we've basically giving them a color-coded chart here saying, if you can, pretty please, group the commons into these particular ones. So, example, this red one up here may be common 1. And so when you go to refresh the screen, it's easier both in software and from a visual refresh point of view to have each sort of group. In this particular case, we have these group of 8 7-segment displays that form a one number. It's better to have them in one common if you can, because then your LCD can update and drive that one common. But either way, it's going to work. It's just nicer if we could have them grouped. And we're just saying, if you can do that, pretty please. Now, we've actually done this in Inkscape, of course, and we'll be able to give them an SVG file, a vector-based file, but a lot of these LCD manufacturers are very old school, just like a lot of PCB manufacturers are quite old school, and they might want a DXF AutoCAD file, for example, so you may have to convert whatever format you have into DXF and actually give it to them. And really, you don't have to get as complicated as this. You don't have to specify it precisely. You could draw it on the back of a napkin if you wanted to, and give them that and say, hey, make us one of these LCDs, and they'll just draw it up or whatever. Like, they may even touch this up a little bit, shuffle things here, shave a little bit off in there, because just remember, when you're actually getting these manufactured, this segment in here, for example, you have to actually allow enough gap in between here not only to route that trace out to ensure that it doesn't touch the others, to actually route out that trace, that conductive trace from this inner one, but then you've got to allow the clearance as well. So that's why we said before, typical spacing and trace width might be 0.1 millimeters and 0.1 millimeters. So, you know, that total in there would have to be 0.3 millimeters if you wanted to squeeze through a 0.1 millimeter conductive trace with that. And then you've got to, of course, route it out to a particular pin. So you can see why if you wanted this segment here connected over to here, they're just gonna, we can't do it. You know, what do these idiots want? You know, they're just gonna absolutely scream at that sort of thing. And basically they might say they can't do it, or they might have a process to do it or whatever. But yeah, just be aware, routing is a big issue with something like this. And of course, you can't just manufacture, you know, something like you couldn't have these solid segments, for example. You have to have the gap between the particular segments. And in this case, look, we've got an inverse one here, and you can see how that we've specified this, and we'll fill this in the table before we send it away. Like CN, that's the segment name for that whole thing. So they would know that all of that content is basically the one, the M, I, and N is just the one particular segment. So they wouldn't do those separately. But down here, for example, with the M, J, W, and H, they wouldn't know whether or not you wanted W and H as separate segments, or whether or not you wanted it as just one segment with WH. So you have to specify that. So we've specified that as 4 separate things there. And of course, we've got like the inverse ones here that just give a nice high contrast. And on stuff like this, like you may be wondering, well, how can this in the middle of the O, for example, how can they turn on that segment? How can they, you know, do that? Like, how do they get the trace out? Well, because it's the one segment. If you wanted 2 separate segments there, you might, like, you're screwed. But, you know, they would have to have a break in there and have the trace coming out. But because it's the same, they would simply add a very thin conductive trace in there that you couldn't see, and you get all that one segment. Like, it's the same over here with this battery one, for example. The little plus and minus in there is all part of that one segment. So they just put the little conductive traces in there. Just leave it up to them. They are going to modify things anyway. They're going to use, because they've got their own internal tools, their own processes, everything else. So you can go to town, you know, with these sorts of data sheets specifying everything, and they just might redo the whole thing. But at least it's clear when you explain it to them. But of course, one of the main reasons you might want to go to town and specify the document here, and the reason we've did it, we've could have told them that, just told them that, hey, we wanted, you know, 6 different 7-segment displays and stuff like that, and then they would have just used their own font for the 7-segment display. They would have used their own font for the characters and things like that, and you may like what they choose and produce, or you might not. So by actually specifying it like this, they will try and get as absolute close to as possible to your particular font here. Like, in theory, it should be exact, but there's going to be some translation from whatever file format you've got into their particular package. But you can pretty much guarantee that it's going to be extremely close to what you specify. Otherwise, if you leave it up to them, you could get the 7 segments that tilt over like this, that are thin and skinny, or short and fat, whatever. It's nicer if you can specify it, but you don't have to. If you've just got a simple product you want to churn out, just leave it up to them. Draw it on the back of a fag packet. And the other reason you might want to specify your own one as well, like in this much detail to the manufacturer, is that you can swap manufacturers, because they might not give you, they're not going to give you their in-house files for manufacturing this thing usually. So, you know, it's not like you can take those files and go to another house, you know, to get the thing manufactured. They go out of business. You might, you know, you want to have multiple sources or whatever. If the more detail you put into your drawing and specifying your LCD, the better chance you have of just simply going to different manufacturers and getting pretty much close to the same LCD produced. There's going to be manufacturing differences between them in terms of, you know, the liquid crystal technology and the twist and all that sort of stuff which goes into the technology of actually producing them. So one might have a slightly better contrast than another one, or might have a slightly better view angle or something like that, but at least they should be pretty close. So there you go. I hope you enjoyed that look at designing your own LCD. It's not particularly hard. It depends on how much effort you want to put into it. The more effort you put into your design documentation and designing the segments and all that. It actually took David quite a while to actually render those segments and design them and things like that and tweak them. It needs to be a little bit fatter here and a little bit thinner there and whatnot. And we actually did a bit of this on the EEVblog forum as well. I think we put it in the supporters section and asked for feedback and stuff like that. And of course, everyone's got their own comments on what it should look and feel like, you know. But anyway, you've got to make a decision. So we're going to get this manufactured. We haven't got it manufactured yet. So that will no doubt be another part of this video coming up soon. As I said, it's like 2 to 4 weeks delivery time or something like that. You probably can get shorter if you really need, you know, express samples. But and just be aware that samples that they produce, they might be able to produce you a sample in a week, but it may not be exactly the same as the production version, maybe in terms of contrast, viewing angle, or whatever. But hey, at least it gives you a, you know, a look and feel prototype that you can physically use, power up, and get your product, you know, like an early prototype of your product working for some dog and pony show you need to take it to or something. Anyway, if you like that video, please give it a big thumbs up. And the other videos are linked in somewhere here. Yeah, somewhere up here at the end of the video. Check it out. Don't forget to subscribe and all that sort of jazz. EEVblog forum down below. Catch you next time.